Hello, hello, welcome. This is a video on sequences. This first question asked if we asks us to determine whether the following sequence is arithmetic, geometric, or neither. And so, if I look at this and I'd say, well, this would be plus 3. But then if I add 3 to 4, I would get 7, not 9. So I can conclude, since there's not a common difference, that it's not arithmetic. Geometric, if it was a common ratio, like if I had 16, let's say 4 divided by 1 is 4, but 9 divided by 4 is not 4, and so it's not geometric either, which means that by a process of elimination, this is neither. Before we move past this one, notice that this is 1 squared, and this is 2 squared, and this is 3 squared, and 4 squared. So it's not that there's not a pattern, it's just that pattern is neither arithmetic or geometric, because there's no common difference or common ratio. So here, describe the pattern for the following sequence and then find the next 3 terms in the sequence. Now here, you could say that maybe would subtract 32. Subtract 32. But if you subtract 32 here, it would give you 0, not 16. So it's not arithmetic. But if you notice that you've got 32 divided by 64 and 16 divided by 32 and 8 divided by 16, all of these are equal ratios, and so there's a common ratio, and they all simplify to 1/2. And so my ratio is 1/2. So the pattern would be times 1/2 or divide by 2, and neither of those would work, since dividing by a number is the same as multiplying by its reciprocal. So these are the 1, 2, 3, first 4 terms. 8 of the 5th, the next term would be 8 divided by 2, and that's 4, and then half of 4 is 2, and half of 2 is 1. All right. On this next one, it says write the explicit formula for the a sub n term, and then find the 21st term of the sequence. Here I notice that this is 2 last. This is subtract 2. There's subtract 2. This is subtract 2. So there's a common difference, and that difference is minus 2. So in general terms, the formula for an arithmetic sequence, for any term in an arithmetic sequence, is a sub n is equal to, for the first term, a sub 1 plus n minus 1 multiplied by the common difference, d. And so that formula is, in this case, a sub 1 is 5 plus n minus 1 times negative 2. And then if I want to find the 21st term, say n equals 21, then I'm going to plug that in there. A sub 21 is equal to 5 plus 21 minus 1 times negative 2. And that's 5 plus 20 times negative 2 times negative 2. There we go. And then 5 plus negative 40, and that would be negative 35. So negative 35 is the 21st term. All right. So on this next one, it says use the following information to write the explicit formula for the geometric sequence. Here, the generalized formula for a geometric sequence is the first term, a sub 1, times the common ratio raised to the power n minus 1. And in this case, I know that a sub 4 is 189, so we've got 189 and a sub 1 is 7. But we don't have the common ratio, but we can solve for it here. So this is the common ratio is r. We don't know that one, so leave that as a variable. N is 4. There's n. N is 4, so 4 minus 1, that would be 3. And so if I divide both sides by 7, if I take 189 and I divide it by 7, I get 27. Over here it cancels. And 27 then is equal to r cubed. Now, I can take the cube root of both sides, because the cube root will cancel that cube, so then r is the cube root of 27. And we can do that in our calculator. If you hit math, the cube root you see is number 4. So I can just hit the number 4. That brings that up, and then I just type in 27. The cube root of 27 is 3. So our common ratio is 3. Now, the formula then is a sub 1, which is 7, times 3 raised to the n minus 1 power. And the 12th, if I want the 12th, then I would say this is 7 times 3 raised to the 12 minus 1 power, or the 11th power. And this would give us 7 times 3 raised to the 11th power equals 1,240,029. 1,240,029. All right, you got this. Keep studying hard.